Well, there may be a little glitch in the video here because I forgot to set up a new page for number 4. And let's try again and see if it works. So what I have to do is to define the Borel sigma field, which is the smallest sigma field that includes all open intervals of the form a to b, where a and b are real numbers. And the challenge is to show that I can make this sigma field from intervals that extend from minus infinity to q. Here on the left, it would be legal either to use a parenthesis or a square bracket. And here, the right endpoints are just rational numbers. So we're going to build this whole gigantic sigma field out of just a countable collection of open intervals. Since I did most of this in sample problem 1, I will be quick about it. The first step is to go from rational right endpoints to real right endpoints. And to do that, I choose an increasing sequence of rational numbers that has a as its limit. The obvious way to do this is just to use decimal approximations to a with more and more decimal places. Once I've set up that sequence, I can form the union from n equals 1 to infinity of these intervals with rational endpoints, and the result, as you saw earlier, is I get a right endpoint of a. It's still an open interval though, and I'm going to need a closed interval for reasons that will become apparent in a moment. So as my next step, I form an infinite intersection from n equals 1 to infinity of intervals of the form that I now know how to make that have a real value a plus 1 over n as the right endpoint. And when I form this intersection, a is in all the intervals, but nothing bigger than a is in all the intervals. So the resulting infinite intersection is now an interval that is closed at the right endpoint. In a sigma field, I'm allowed to form complements. And if I take the complement of what I just made, that extends from minus infinity up to and including a, the complement of this is everything that's greater than a, in other words, the open interval from a to plus infinity. And now I'm home free because I'm allowed to form intersections in a sigma field. I will take the intersection of the interval that extends from minus infinity to b with the interval that extends from a up to infinity. The only numbers that are in both of these are numbers that are greater than a and less than b. In other words, I have succeeded in creating the open interval that extends from a to b. Now to see whether my attempt to salvage this recording was a success.